Hello friends, so in today's video we will talk about exception handling in Python. So without wasting time, I am sharing my screen. So right now you can see a Jupyter notebook. So to begin about to begin the topic exception handling, you might have come across multiple errors while running your Python script, right? There are two type of error basically. One is compile type error, that is nothing but a syntax error you can say, and one is runtime error. So when we talk about runtime error, that means logically or syntactically your code is right, okay, but based on the runtime environment, like whatever values your code is expecting or particular file your code is expecting, but that is not present, or if it is present, it is not present in a correct expected format, then you will get some error. Whatever logic you have written in your code, that is correct, but whatever inputs your file your code is expecting, that is not, that your code is not getting that as per expectation. So whatever error comes into picture because of that scenario, we call it runtime error, right? So exception handling is is a way to deal with that runtime errors, right? So let's talk about it. Basically, if I write a equal to 10, syntactically it is right? But if I try to divide a, the value of a is 10 right now. If I try to divide a by, if I take one more variable, that is b, and I'll take input from user, okay, and my code is expecting some number which will be stored in b. But in the runtime, if user is providing number 0, okay, and if my code is trying to do a by b, a divided by b, so if it, and you can see there is an error now, and it is nothing but a runtime error. Why? Because you are trying to divide a, which is 10, by 0. So if you try to divide any number by 0, its output will be infinity as per the mathematics. But from coding perspective, you will get this error, divide 0 division error, because it is not allowed to divide any number by 0. Similarly, instead of 0, if let's assume this time it is expecting some number, but instead of number, the user has given some text input, that is string. And after that, when I try to run a by b, still it will give error. And that error will be, here itself I got the error. Why? Because whatever input I got, that input, it is trying to convert it into an integer. But since our input is string, you can't convert that string into integer. So that's why the error you got here is invalid literal for int with base 10. And this is the value the user has entered. So these are the runtime error. These were the example of runtime error. Now what happens? I will write the line of code, that is a equal to 10, b equal to 0, and a by b, and then I'll write print whatever, display this message. Okay, now you know our code run as per the scripting method, like that is nothing but line by line, one after other, top to bottom, right? And there are total 4 lines. Let's say if error occurs at line number 3, which is going to happen, and that error will be division by 0 error. So then even if there is a error, runtime error in line number 3, but still because of that, whatever is written after that, that is line number 4, 5, 6, whatever is written, that will not, that will be skipped, that will not get executed, right? So what happens in runtime, if you come across any error, and if your code is long enough, then we can say because of one error, your code will stop working, and whatever is written after that, that won't get executed. So that's where exception handling comes into the picture. Because of exception handling, what you can do, that a runtime error will be handled in exception. Definitely you won't get expected output for that particular line of code where error occurred, but whatever is written after that, that will get executed. Okay, and in order that to happen, like whatever error is there, just handle that error and then keep on running the code as per the logic to make your code in that particular way. You should include exception handling in your code. So I'll show you here. See, there I'll line number. Okay, you can see there was error at line number 3, and that is nothing but zero division error, but because of that this print message didn't work. Okay, now I told you all the basic and theoretical part about exception handling. Now let's see how you can write that syntactically. So in above code itself, what I'll write there, I can write try. So there is a try block. Try block means whatever line of code you are doubtful about, you have suspicion that there might come any kind of error, any kind of runtime error. Okay, if syntactical error is there, that you will get to know while compiling your code. Okay, so you can't handle the compilation error or syntactical error using exception handling. It is only and only for runtime error. So try block is, you should write all the suspicious code, line of codes where you have doubt, like error might happen, you should write that in try block. So the syntax for try block is simple: try, then colon, then hit enter. Then you can write whatever you want to write over here. So I'll write a equal to 0, or I'll say not int input. I'll take input from the user. Okay. Similarly, b equal to int input, something like that. Then I'll do a by b, and this is the line where we have doubt. Then once that is done, now I'll write I'll just run this code. See, this time you got error, but that is not that like it is not a runtime error, it is syntactical error. There is a reason. Let's check why it is that is the case. Like whatever are the line of code where you have doubt, you can write that in try block. Along with try block, there always comes a exception block. Like whatever error comes into try block, that gets handled using exception block. So the syntax for except block is except, one second, something is wrong. Yeah, small case, except, and I'll say print there was error. Okay, now I'll run this code. Now you can see the syntax is complete now. So it is asking me the value for a. First time it is asking me the value for a, so I am typing something like 34. Now it is asking me the value for b, so I'll write 9. Now there is no error, and it run the try block as it is without any error. So that means if there is an error in try block, then and then only it will go into except block and run whatever is written in except block. Otherwise, if there is no any error in try block, then it won't go into except block. Now I'll run this code once again. Here I'll write the first value as something random value. Then I'll write b as a 0. See, because there was error at line number 3, because division by 0 was not possible, so our code went into a except block, and whatever is written there in except block, it printed it as it is. There was error, right? Now I'll make some changes. I'll write print statement. Print this message. Okay, and I'll run this. Now again, I'm giving a some value that is 23, then 0. Now definitely there was an error. Okay, that is nothing but division by 0 error. So it went to except block. Whatever line of code you have written in except block, it executed that. It was nothing but a print statement in our case, and whatever is written below that, that also got executed. So like in our earlier case, once the error occurred, whatever is written below that was not executed at all. But here you get around the error. There was error. You get around the error. You print that message and you go forward with that error. Whatever is written after that, you keep on executing. Your code will execute that. Now, the next part is, there was an error, but here whatever we have written is printed, but we don't know what kind of error happened. There can be multiple error. Right now we know because our b value is 0, the error was definitely division by 0 error. But if instead of this, if I run it once again, and if I take some, it is expecting some integer value, but I am providing some string. See, there was error, but this time the error was not division by 0. The error was different. It was expecting some value, but it is not getting that value. So that was a different error, but still it printed there was an error and print this message, right? Now the next part was, I want to print what was the error. Okay, the user should get to know what was the error. Then how to do that? I'm just copying this code, I'm pasting it here, and I'll do one thing. Instead of just writing except, I'll write except exception as E. So basically what is happening, there is a superclass named as exception. Okay, see, whatever is written over here, you can write, someone can think that instead of writing try and except, we can write if else, if else, if else, saying that we'll check if the value of b is equal to 0, then print there is division by 0 error, and something like that. Like you can write multiple if else statement and you can handle error on your own. That some person can think like that, but the problem is, a new developer or a developer like me, we can't be sure like what all exception, what all error can come into a picture. For that, one good news is, the list of all possible errors is present in this superclass, that is exception. This is a superclass. Within this class, there are so many subclasses for each error. For each type of error, there is one subclass. So right now what I'm doing, I'm writing except block, calling a superclass as E. So E is a variable name. You can write anything instead of E, but right now I'm writing E. And if I do something like this, okay, and let's try. I'm trying to print this E over here in print statement. So if I do this, and if I provide some value, the value for A is 45, value for B is 0, and you can see there was error. This is the message given by me, written by me, and then after that I tried to print E. So what was written in E? Division by 0. So now we know what error actually happened. So I'll write something like that, and I'll run this once again. So some value, then 0. You can see there was error. And what was error? That error, the name of the error was written in, like present in this variable E. With this syntax, you can get all the error. Instead of this exception, you can see there are some subclasses, and the name of those subclasses are like this. This division 0 error, it is also a subclass. Instead of exception, I can write something like I'll just copy this, and I'll just copy this class name, and I'll write except 0 division error as E, and I'll do this. Here see, again I'm providing some random value to A, then 0 value to B, and you can see there was error, and whatever is the name of error is written over here, captured in E, and printed, that E is printed over here. So you can see what error actually happened, and whatever is written after that, that is handled because of exception handling. Now instead of division by, here since I extended this except block using this subclass, but instead of this, if I run this code once again, and instead of value 0, if I try to provide some string value in A, still I got some error, right? But you can see this error is not handled here. Why? Because when we extend this except block to a particular subclass, then this particular except block can handle that error only. If you want your except block to handle all kind of error, you should make the practice that instead of extending your except block to a particular subclass, just extend your except block to a superclass, that is nothing but an exception. It is the exactly same code as above, but if I run this, and instead of a number, if I try to provide any string value to A, you can see still it handled that error. So if you are not aware, if you are not sure what kind of error that can come into a picture, then you should always write this, use this exception class. It will handle all kind of error which are possibly present, which can possibly come into a picture. Okay, now you will see some people can say it is not good way to use this superclass directly. It will search for all kind of error and it will be a heavy code. Some people can say that. Then okay, now in this code I am expecting two different kind of errors. Okay, the first error was division by 0. The second error was what was the second error? Name of the second error is nothing but a value error. Okay, whenever I pass a string into a b and try to convert that string into integer, I'll get value error. Okay, so I can do that also. I can handle multiple error using multiple except block. So you can write multiple except block for a single try block. I'll just copy this code and I'll show you. So instead of this exception, I'll write zero division error. Now I'll write one more except block, that is nothing but except, and I'll write value error there. I'll just copy this value error. It is a subclass of an exception class. As I'll write even here, I'll write as E2. I'll try to print E2 even. Now you can see I have written two except block for one try block, right? Now let's see what happens. If I pass some value to A and zero value to B, I got division by 0 error. One second. Oh, sorry. There was a mistake. I should write even here. So I'll run it once again. So I pass some random value to A and 0 value to B. That division by 0 error was handled and this line was printed. Okay. Instead of that, if I run it once again and instead of 0 value, if I try to provide some random string into that, still that error also got handled because of this exception block E2. Okay, you can see that. Similarly, you can write multiple exception block. Now let's say instead of this, if I try to write same, I'm adding third except block. That is nothing but except exception as E3 print this was error comma E3. Now see what I'll do. I'll pass 0 value to B. So basically there will be a 0 division error. So 0 division error can be handled using this block and can also be handled using this block, right? 0 division error block and exception block. Now let's see what I'll write. I'll write even here so that we will get to know what exactly got which block gets executed. E2 and I'll write here E3. Okay. Now let's run this. I'm passing some number to A. I'm passing 0 to B. Still it printed even block. So why it why it ran even block, not exception block? Because if there are multiple except block and a multiple, like if there are more than 3, 5 or more number of except block and whatever error occurred, that error can be handled by multiple except block which are present. Then it will go sequentially. Whatever is written first will get that except block will run first. If I move this block from here to here, right, correcting the indentation, and if I run it once again, then you can see I am passing some random value to A, then 0 value to B, but this time E3 got executed because even E3 can handle this error and even can also handle this error, right? That's why whatever is written first sequentially, that will get executed. In the same code, if I pass some random string to value A or B, whatever, then that error can be handled using this E2 block and E3 block. So in this case, the E3 gets executed because it is written first. If I move this block from here to here and pass same value, you can see this time E2 will be executed instead of E3 because it is written first. So now you are aware of try and except block. There is one more block that is nothing but an else block. And this else block is present only in Python. If you look into any other programming language like Java, you won't find else block there. So I'm just copying this code as it is. Now I'll remove the remaining except block. Now you understood the concept of multiple except blocks, and I'm just writing even here and even, and I'll write else block, else. Okay, and I'll write print this is else block, right? Let's see if I pass some value. See, there are multiple ways to get error, runtime error, but for ease of providing an example, I'm using just this input function and trying to convert it into int. Similarly, we can do the same for file handling. If I try to read a file and using a open function, and that file is not present, still you will get some kind of error, and that error can also be handled using try except block. But I'm just sticking to this example for now. So I'm providing some value for A, that is 56, and I'm providing 0 for B. So you will get some error, right? And then except block is got executed. That's fine. But you can see else block didn't get executed at all. Whatever is written after the else, that got executed, right? So I'm running this once again, and I'm providing some really good values apart from 0. So 34 is the value for A and 5 is the value for B. Now you know try block got executed successfully without any error. Then you can see the else block also got executed. What does that mean? That means else block will get executed when try block gets executed successfully without any error. Okay, so once again I'm postponing this. Okay, so that's the case. So else block will get executed only and only when try block gets executed successfully without any error. So that is the use of else block. Now there is one more block, that is finally, and finally block is present in any of the programming language. Even if you look into Java, you will find a finally block. So I'm just copying this here. Before that, I'll write some information about else. So else block will get executed only if try block gets executed successfully without any error. Okay, fine. Now there is one more block, that is nothing but finally. I'll write finally and I'll write print. This is finally block. Now let's see what happens. I'm trying to run this code. I'm providing a some value to A and I'm providing 0 value to B, so that there will be error in try block. That's for sure. Now you can see because of error, except block got executed, right? If there was no error, then except block doesn't get executed. Then else block will get executed, right? So right now there was error. That error was handled due to this except block. Okay. Else block didn't get executed. Why? Because there was error in try block. But finally block gets executed. You can see this message. This is a finally block. That means finally block gets executed when there was error in try block. Now I'll run this code once again, and this time I will provide some correct values to A and B. So there is no error at all in try block, that's for sure. And you can see still, so this time the except block didn't work, like it didn't get executed. Else block gets executed because of successful execution of try block. At the same time, you get the finally block also gets executed. You can see this message over here. What does that mean? Even if there is error in try block or there is no error, like whatever happens, whether there is error or no error, finally block will get executed for sure. That's why its name is finally. Irrespective of, I'll write it down here, irrespective of whether there is error or not in try block, finally block will always get executed, right? So that is the case. 56 0, there was error, but still finally block got executed. Similarly, I'll write message for except block also here. This notebook will be available to you. If you go to description, you will find a link to this notebook. That's why I'm writing down all the main key points. Except block will get executed if there is error in try block, right? I'll write only if there is an error in try block. That is fine. So now you understood try block, else block, try block, except block, else block, and finally block. Okay, you got the idea for all the four. That's it. Now there is a next thing. I'll just copy this code as it is over here. Now there can be a nested try except block, else block, final block. There can be nested things. What does that mean? You can write try block within try block. Okay, something like this. I'm not writing down any line of code. Then except block within this. I think there is a syntactical error, something like that. Similarly, you can write this try except block within this except block. Okay, within this else block. At the same time, you can write try block within finally block. Okay, logically, why it is available? Let's say you wrote some logic in try block. If there is error, then you need to perform some kind of operation which you will write in except block. If there is no error, then you want to perform some different kind of operation, you will write it in else block. And irrespective of if there is error or not, you will write some kind of logic in finally block. But there are chances you are suspicious about whatever line of code you write in finally block. Okay, and there can be some error, runtime error, which can occur, which can happen for this error highlighted portion, whatever you write over here. So how will you handle the error which is going to happen over here? So for that, you can write a try block inside a finally block, else block, except block, anything. Okay, so I can write something like this: try. Okay, and I'll write except print this is except block within finally block. Okay, and instead of print statement in try, I'll just write down one thing. I'll write down c equal to int input some value, right? So I'll run this. So basically what I want to check, I'll pass some value to a, some value to b. Now we're in finally block, right? Because there is no error in our try block. It went to else block, it printed that. Now it came to finally block. Now it is trying to get the value for c, and it will convert that value into a integer. So I'm passing some wrong value, some string. So there was error in finally block, and that error also got handled here because of this except block. And you can see whatever is written after that, that message also got printed, right? So that means we handle all kind of error, runtime error. So that's it, guys. This was all about try, except, and finally block and else block. There is one more thing. Sometimes there might be situation, let's say again with the same example, I'm taking a as an int and input. So by default, if I try to pass some string value and try to convert that into an int, it will give me, it will throw an error, okay, internally without any without doing anything else. But there might be situation, as per my logic, I want to get only positive integers. I don't want any negative integer at all. But there is no any logic written by default which will raise an exception if user enters negative value. Let's say this is a, and if I pass -6, it will accept it. Okay, it will take that input -6, convert it into an integer. If I print a, it will show me -6. But what if I want I I want the value to be always positive or 0. I don't want any negative value, and I want to raise an exception if user enters some negative value. Okay, like user defined exception. I'll call it something like that. Now, how to do that? So there is a way for that. There is a keyword raise. So I'll show you. One second. Okay. So for that, there is a way. There is a keyword. 1 second. Okay. So what I'll say, I'll write a equal to int input, something like that. I'll say if a is less than 0, then I want to raise an exception. So what I'll say, raise. Okay, exception. And raise exception. 1 second. Let me check the correct syntax because I'm not using it for a long time. Okay, and I'll say return a. Let's see what happens. Now I'll pass some value 8. What happened? Okay, sorry, that was my mistake. I just copied it from a function. No need of that. I'll just write print a. Let's see what happens. I'm passing some value 67. That's it. Okay, that's it. If I try to pass some negative number, let's check. -7. Okay, it raised an exception and it printed this. When I write, if I remove this, let's see what happens. If I pass -89, see, it raised an exception for a negative value because of this logic, whatever we have written over here, right? So in this way, we can raise an exception. One more example I'll give you. If I'm doing the same operation within a function, if I write a function that is def positive integer int, okay, and if I do the same, a equal to if a is less than 0, then raise accepts. Here also you can raise different. It is a super class. You can use subclass if you want to go for a particular type of exception. And I'll say return a. Okay. Now I'm calling this function positive integer, and I'm passing a value that is 8. So since it is a positive thing, no error at all. If I pass -8, it will raise an exception, and that is written over here. What if I want to pass a custom message with this? So I'll change this. I'll just copy this here, and whenever I raise an exception, I can pass a message over there. So I'll say this is a negative integer. Okay, space, and now I'm calling my function and passing a negative value. Okay, I'm running this. Now you can see you can raise a exception, and you can pass whatever you want to whatever message you want to pass for the user. You can pass it over here. So it said this is a negative integer, and this is the like whatever the negative value is entered is written over here. So in this way you can raise an exception. I'll tell you, instead of this super class, if I use some other class, like instead of this exception, let's say I write division by 0 error, like that class name. whatever is here, right? So I'm raising that exception here. If you want to raise particular exception, you can do that. Now I'm calling the same thing and I'm passing some negative value. You can see I'm just running this. You can see it raised this exception, whatever function you call, whatever exception class you call, that exception is raised, right? So in this way, you can raise any of the exception. You can override whatever message you want to pass within that. Okay, so that message can be overridden in this way. So this is the way to raise an exception. So in this video, what the topic we have covered are what is a try block, what is a except block, what is a else block, and what is finally block, and when which block gets executed. Then how to print a custom message to handle that exception. At the same time, if you want to print like what error occurred, what is the exact error occurred, you can do that using this syntax: accept exception as e1, e2, e3, or any variable name, and you can just print that within that. So that is the way to print the actual error which happened, which occurred. Then I have shown you there can be multiple except block for a single try block. Then I have shown you there can be a nested try, except, else, and finally block within a try, except, else, and finally block. There can be nested thing. And then at the end, I showed you how you can raise your own exception. If you want logic for your own logic, you want to raise an exception, then you can do that using this raise keyword. This raise keyword followed by the exception class name. If you can go with the super class, that is exception, or you can go with a specific subclass. For example, zero division error here. Fine. So this is all about exception. Irrespective of whether it is mentioned or not, you should try to handle exception in your code. That is a correct way. There were some real life accident, aeroplane crash happened because exception was not handled in the code within that aeroplane. Whatever code was written for handling that aeroplane, exception was not handled, and because of that, we had to lose many life. And that is a standard practice. You should always try to handle exception in your code. So that's it, guys. Whatever in all of my videos, whatever I write in front of you on this screen, all those code will be available. Just go into description, you will find a link over there. Click on that link, you will find all that notebook, all the codes written by me. So I hope you got knowledge from this video. If you like this, please do anything you can do to encourage me. Like, share, comment, subscribe, do each and everything to encourage me. This is Akshay Daga signing off. Thank you. Bye bye.